Brexit, was it optimal? We will be analysing the trade negotiations in Brexit and we will therefore find the optimal outcome in the context of bargaining. We will have four types of deals that the UK government will determine by the 29th of March, but the one we'll focus on will be a no deal. This is a clean cut from the EU with no transition period. The UK follows the most basic trade rules, that of the World Trade Organization. Here I'll introduce the BATNA, which is the best alternative to negotiated agreement. This is the disagreement value each party receives if they walk away from negotiations. For the UK, it will be World Trade Organization rules, and for the EU, it will be no trade with the UK. What inspired my study? So the M3 would be used as a lorry park on March 29th if the UK faces a no deal. I wanted to investigate why, and I found that UK ports would be blocked up due to immigration checks if we hit a no deal. The bargaining problem. So the UK is the first player, the EU is the second player. So the UK wants to buy trade with as little commitment to the EU, and the EU wants to sell trade with as much commitment from the UK. The diagram illustrates the antagonizing levels of commitment. So the axis shows commitment, which we can think of as the price, thus we can think of the trade as the good. So the dark blue EU bubble shows the minimum commitment the EU will accept, and the dark blue UK bubble will show the maximum commitment the UK will give. The distance between them highlights the surplus utility from trade that can be obtained, in other words, the money on the table. The pink lines show direction of utility increase, but how do we split the surplus utility from trade, or in other words, at what level of commitment should the parties agree on? So modeling the problem. The type of game I will use is an alternating offers model in the style of Ariel or Rubinstein. We will make four assumptions: perfect information, both players know each other's batners, infinite horizons, the game can go on indefinitely, as will be shown in the extensive form game in the next slide. We assume stationary strategies, which means every odd round is identical and every even round is identical in terms of offers. In terms of discount factor, this is the value between 0 and 1, and it tells us how we value one util in the present, in the future, in present terms. Therefore, the higher the discount factor, the less heavily discounted the future, and players are less impatient. Here is the extensive form game, which I urge you to take a look at. And note that in an odd period, the UK is making offers to the EU, and in an even period, the EU is making offers to the UK. Solving the game, I have to introduce the fixed continuation value. This represents some non-discounted amount that the EU will receive by the end of the game if they reject in an odd period. Note it's stochastic and unknown. So note that we are also using utils as our unit of value since we don't know the trade deal in monetary terms. So here's how we solve the game. In any odd round, the UK must offer the EU their continuation value in order to make the EU indifferent between accepting and rejecting. That is, in an odd round, the UK will offer the EU equation 1 and will keep for itself equation 2. Thus, by backward induction, in the previous even round, the EU offers the UK a value, equation 3, that makes the UK indifferent between accepting and rejecting. Recall that VEU is the EU's payoff if they reject in an odd round. If so, the game advances to an even round where equation 4 becomes their payoff. By equating equation 4 and VEU, we solve that VEU equals 1 over 1 plus delta. Equations 1 and 3 tell us what the proposer should offer in any round, and by subbing VEU into equations 1 and 3, we can show that the proposer should always offer delta over 1 plus delta, which is the subgame perfect Nash equilibrium. Thus, in every period, the proposer should offer delta over 1 plus delta, and the receiver accepts any offer greater than or equal to delta over 1 plus delta, and this solution is realized in the first round. Interpreting the solution. So, because we have no arbitrary units, we can only make a relative inference. The UK is more impatient as it's promised a result to its public by March the 29th. The UK has already been rejected, thus they should accept a really low share of the surplus utility from trade, hence they should propose a marginally high level of commitment. Critiquing this model, we have unreasonable infinite horizons, but this is more to illustrate that the players don't know who will have the last say. Discount factors will be different for both parties, and we expect the UK to have a lower discount factor. Perfect information doesn't exist, and impatience isn't the only source to bargaining power, but what is? So we have the impatience. So we've looked at impatience, risk attitudes. The UK is more risk averse. It wants to strike a deal ASAP to avoid breakdown. EU holds bargaining power. In terms of outside options, the no deal doesn't affect the EU as much as it does the UK. Thus, EU holds bargaining power. In terms of inside options, a longer negotiation process means the UK is still trading and committing, so the EU holds bargaining power. Commitment tactics. So through rose-tinted glasses, the UK majority voted to leave. This relatively large cost of backing down gives the UK bargaining power, and the UK was uninformed in the referendum. This decision underlies the stance of the UK government, thus we have less bargaining power due to less information. The lessons we have learned is bargaining power and where it comes from, thus how can we maximize our own bargaining power. We've looked at the Rubinstein model to mathematically model our own bargaining power and see when we're getting a fair deal and when we're giving a fair deal, although it has its limitations, and we know that the UK will incur an inevitable trade loss based on bargaining theory. Thank you for watching, and we look forward to March the 29th.